Hello everyone. In this video, we will talk about how to implement bisection method in MATLAB for the purpose of root finding. Let's see this question. Consider finding the root of fx, which is equal to x cubic minus 2. And we start with the interval from 0 to 2. And we assume that epsilon step is equal to epsilon abs, and both of them are equal to 1e negative 5. The first question asks you to write all the codes in the main file, and the second question asks you to write the codes in the main file and a separate function file called bisection.m. So let's see the first question. Before we write all the codes in the main file, let's see if we can create a function file for this equation, fx equal to x cubic minus 2, because if we create a function file for this equation, then every time we want to use it, we just call the file f.m instead of write x cubic minus 2 every time, right? So let's do that. Create a file, which is a function file. The output is y. The function is called f. The input parameter is x. And y is equal to x cubic minus 2. Okay, then we can save it as f.m. Okay, so let's write the main file. If you want to see more digits, you can format long. And then let's define the constants. So you see here, we start with the interval 0 to 2. So a will be equal to 0, b will be equal to 2 initially, and two constants are 1e negative 5. So a equal to 0, b equal to 2, epsilon step equal to 1e negative 5, and epsilon abs equal to 1e negative 5. Then we can use a while loop to do the iterations. While a certain condition is satisfied, then we can do the iteration by finding the midpoint of this interval, which is c equal to a plus b over 2, right? Remember in the previous note, it says that after you find the midpoint, there are 3 different scenarios. The first one is that the midpoint happens to be the root, which is very unlikely in practice, but it's possible. So if that happens, then we can stop the iteration process because we have already found the root, which is c. So if fc equal to 0, then the root is found, which is c, then we can stop the iteration process. Okay, the second scenario is that fa and fc have opposite signs. If that happens, the root must be located in the interval a to c, and we can remove the interval c to b by assign the value of c to the variable b, right? Else if. So fa and fc have an opposite sign, which means fa times fc is less than 0. Okay, then we can assign the value of c to the variable b. And the last scenario is that fc and fb have opposite signs. Then the root must be located in the interval c to b, and then we can remove the interval a to c by assign the value of c to the variable a, right? So a equal to c. So these are the 3 different scenarios. Okay, then we can end this while loop. So the question is, what's the condition here for the while loop, right? let's go through the previous note. Remember that the halting condition is that we stop the iteration process if condition A and condition B are both satisfied, right? So condition A and condition B are both satisfied. And condition B includes condition B1 and B2. So condition B is satisfied when condition B1 or B2 is satisfied. Then we halt. So this is the halting condition. So let me write down condition A means the width of the interval is sufficiently small, which is B minus A less than epsilon step. And condition B1 means the absolute value of FA is less than epsilon ABS. And condition B2 is that the absolute value of FB is less than epsilon ABS. Okay, so this is the halting condition. However, when you write down the condition for the while loop, this condition should be when this condition is satisfied, then we continue the iteration process, which should be the opposite of this halting condition, right? So the condition we write in the while loop should be the opposite. If this opposite condition is satisfied, then we continue the while loop. So the question is, what's this condition, right? What's the opposite of this halting condition? So let me tell you. The opposite of this condition is the opposite of condition A or the opposite of condition B and the opposite of condition B1 and the opposite of condition B2. So this will be the one that we need to write in the while loop. Okay, so the opposite of condition A should be B minus A larger than or equal to epsilon step, right? And the opposite of condition B1 is the absolute value of FA larger than or equal to epsilon ABS. And the opposite of condition B2 should be the absolute value of FB larger than or equal to epsilon ABS. So the condition for the while loop, while, should be B minus A larger than or equal to epsilon step, or the absolute value of FA larger than or equal to epsilon ABS, and the absolute value of FB larger than or equal to epsilon ABS. So this should be the condition for the while loop. Okay, before I write this in the MATLAB code, let me explain why the opposite of the halting condition is like this. Okay, let me give you an example. For example, right now I have a scholarship. The condition for you to get this scholarship is that you satisfy two conditions. The first one, condition A, is that your GPA is higher than a certain value, okay? And condition B is satisfied when condition B1 or B2 is satisfied. And condition B1 is your sister's GPA is higher than a certain value. And B2 is that your brother's GPA is higher than a certain value. So as long as one of them is higher than a certain value, then you satisfy condition B. And also, if you satisfy the condition A, which means your own GPA is larger than a certain value, then I will give you this scholarship, right? So what's the condition that I don't give you this scholarship? So if you don't satisfy this requirement, okay, your own GPA is lower than or equal to this value, or you don't satisfy the second condition, okay? The second condition, you don't satisfy the second condition, which means neither your brother nor your sister satisfies this condition, right? If one of them satisfies this condition, then condition B is satisfied, right? So you get this scholarship if you satisfy condition A and condition B. But if you don't get this scholarship if condition A or condition B isn't satisfied, right? And condition B isn't satisfied, which means neither your brother nor your sister satisfies this GPA requirement. Okay, so this is a simple example, and I hope that you understand. So then we can write the condition into the while loop. B minus A larger than or equal to epsilon step, or the absolute value of FA larger than or equal to epsilon ABS, and the absolute value of FB larger than or equal to epsilon ABS. All right, so this is the while loop. And so here we find the root if the first scenario happens. So what's the root if the second or the third scenario happens, right? So in the end, so if we find the root because of the halting condition is satisfied, so this condition should be the opposite of what we write here. Okay, so if the halting condition is satisfied, which means B minus A less than epsilon step, and the absolute value of FA is less than epsilon ABS, or the absolute value of FB is less than epsilon ABS, right? If this happened, then we find the root because the halting condition is satisfied. So then we can compare the absolute value of FA and FB to see A or B, which one is a better approximation for the root. So if absolute value of FA is larger than the absolute value of FB, then B is a better evaluation of the root. So else, if the absolute value of FA is less than the absolute value of FB, then A is a better evaluation for the root, right? Okay, so this will be the whole function, so we can run this to see if we can get the root, okay? Okay, so you can check the root cubic minus 2 if this is almost 0, right? So which means it's correct. And however, you remember that this question actually asks you to write all the codes in the main file. However, in this practice, we create a separate file to build this function, right? So how to write all the codes in the main file? So let me explain to you. There are actually two different ways of defining a function. So the first one, so define a function. You can use a function to create a separate function file called f.m. For example, it can be called anything, but in this example, we called f.m. And the content for this function is function y equal to fx and y equal to x cubic minus 2, right? Then this will be a separate file, right? And if you don't want to create a separate file, if you want to write all the codes in the main file, so you can do that. So in the main file, you need to define this function f equal to at. There is an at symbol, and then this function is about x, so x cubic minus 2. Okay, so if you write this line, in the main file, you don't need to create a separate file, right? So if you do this way, without you don't have to create without creating a separate function file. Okay, so we can remove this file and define the function in the main file. So f equal to the @ symbol x and x cubic minus 2. Okay, so then we can run this file again, so you can see it still works. All right, so then this file satisfies all the requirement. Okay, it's written in one single file. All right, so let's see problem 2. Write the codes in the main file and a separate function file bisection.m. So to do this, we can put the bisection, the codes about bisection method into a separate file. For example, here we have defined a and b and 2 epsilon constants and also the function, right? Then we can call a file bisection. If you call this function, you get the output parameter root, right? And the input parameter is the name of the function f and the 2 endpoint a and b, and also the 2 epsilon constants, epsilon step and epsilon abs, right? Then we can remove this part. Okay, so we create a bisection.m function root equal to bisection. The input parameter is f, a, b, epsilon step, epsilon abs, and then we can move the other codes here to the function file. Okay, so we can save this as bisection.m, and then in the main file we can call this bisection file to find the root. So let's call this, and then you see you find the root here, right? So you can change the interval every time. For example, you can, instead of use a and b, you can write 0 to 4, 0 to 3, for example, and this epsilon can be 0.001, and this one can be 0.001, right? Okay, so you can run this again. It may give you another root. Okay, so this bisection, it's a very general function, right? So you can use this bisection file to find a root for any nonlinear equations, as long as you know the interval and you have 2 epsilon constants and it satisfies the initial requirement, which means fa and fb have opposite sign initially. So let's see, for example, for the problem we tried in example 1, which is x squared minus 3, the interval start from 1 to 2, and we have epsilon, which is 0.01, epsilon ABS is also 0.01. So let's see what happens this time. So remember that we solved this problem before, and in the previous note, the result is 1.7344. So let's see if we get the same result here. 1.7344, right? So it looks good. All right. So you can use this bisection file to solve the root finding problem as long as you satisfy the initial requirement. Okay, so let's see the quiz problem for this class. So this will be the second quiz. The upward velocity of a rocket can be computed by the following formula. So V equal to U times ln m0 over m0 minus qt and then minus gt, where V represents the upward velocity, U represents the velocity at which the fuel is expelled relative to the rocket, and m0 represents the initial mass of the rocket at time t equal to 0, Q represents the fuel consumption rate, and G represents the downward acceleration of gravity. Okay, and G, U, M0, Q are constants, which are all provided to you. And the question asks you to use bisection method to find the time t at which V equals to 750 meters per second. So the initial guess is that t is somewhere between 10 seconds and 50 seconds, and we assume that the two epsilon constants are 0.001. So you need to write the codes in the main file and a separate function file called bisection.m. So after 40 minutes, you need to submit your codes. Good luck.